Okay guys, welcome back to our channel. Let's get started with the problem of a day of lead code. So the problem name is binary tree level order traversal. Okay, so you have given the root of a binary tree, return the level order traversal of its nodes value, that is from left to right, level by level. Okay, so what the question is said that we have to give the level order traversal of this tree. So what will be the level of order traversal? It should be 3, 9, 20 and 15 and 17. So it will be like 3, 9, 20, and it should be in a array form, it should be in a vector form. We should give the answer in a separate vector form. Okay, so we will make sure that we give the answer in a separate vector form. Okay, so let me explain you the question. This okay. Just a second. Okay, guys, right, so what is given, like, okay, okay, so the array we have given to us is this. Okay, and we have to give the answer into a level order traversal. Like, if suppose the array is given like this and 9, okay, and 9, and this is 20, and from 20 we have 15 and 7. Okay, and we have to just give the level order traversal of this tree. So what will be the level order traversal? It should be 3. Okay, for 3, why it should be 3? Because we have to consider root element also. So for a single root element, we will be stored into this form. Okay, in a vector form. Okay, so in a vector, 2D vector. Okay, we will create that. Okay, and now doing so, we go to the root left and root right. Okay, and we see that these are the level order traversal for 3. Okay, so we store into this in a vector form, which is 2D vector. Okay, now again we go for 20. For 9 we see that it is null, so we directly return from there only. Okay, this is return statement. Okay, and for this we go to the 15 element. For 20 should be like 15 and 7. Okay, this is this we have to return to our answer. It is called a level order traversal for a binary tree. Okay, so guys, in this question you can do with a DFS also and a BFS also. Okay, on the what the method I have done on this question, it's like I have done with BFS only. Okay, so you can do with a DFS also, because it will be a very easy approach. Okay, so I will be telling you with the BFS approach, and for DFS I'll give you the short idea. You can implement by yourself only. Okay, so what we will just do, like, we will start from a 0 index. Like, if we take for a recursion method, if you are, what is DFS? Like, we explore all the nodes. Okay, just a second. Okay, yeah, we explore all the nodes. Okay, we explore all the nodes, and then we will satisfy our then we go to the next loop. Okay, next loop or next regression call. Okay, so it will be like this. Okay, so like, if you are standing over here, and if we take a like a up variable, which is we are calling in a recursion function, and we pass the root element into a recursion. Okay, so if we pass the root element and we call as a up function. Okay, so we first of all see that our if we take as a vector array, which is a 2D vector, up value, which is 0. So 0 is equal to 0. You just normally just store this answer into a vector form. Okay, so right now it will just store our answer into a vector form. Okay, and similarly we go to then we again call a DFS for left function and for right also. So if we call for a right for 9, it will go to this in a loop, and it will see that what is the level. So we have incremented our level, which is 1. Okay, which is incremented our level 1, and if we see that what is the size of a cube, what is the size of a vector, it should be 1. So 1 is equal to the 1. Okay, so 1 is equal to the 1. So you just store that element into a vector. So it will become like which is 9. Okay, so we store that element into a vector. Okay, so next time we just call this element, we see that it is the index we are calling it is empty. Okay, so if we see that it is empty, so we don't call it again and again. Okay, so next time we go to the next loop, which is a 20, and we see that level was increased by which is 1 plus 1. Okay, so 1 plus 1, we just store that answer into a array, which is 20. Okay, so this is a DFS traversal. You can implement by yourself. Just draw a tree, recursive tree. You will understand by yourself only, because we are just doing this condition like if null, just return. Okay, just return, and if just a second. Okay, just return if it is null for DFS. Okay, for DFS if it is null, and for size what we are doing, just for size, if the vector size is it equal to the up size. Okay, if it is though, so you just store that the value of the grid, or the value of the level which we are at it. Okay, yeah, so you just store that vector dot push. Okay, just push back the element. Okay, just consider that only. Okay, and now we will just call the recursive function, so which is called as root dot left. If we take suppose solve function. Okay, so root dot left. Okay, and similarly for the solve for root of right. Okay, right. So this will be a DFS function. You can implement by yourself. It will be very easy to understand. Okay, and now we come to the which is our function which we have write is like a, yeah, right. So we have write the function which is called as a BFS. So what is a BFS function? If it is for this case, if you are getting null, if your root is equal to null, you just return the empty array, just null. Okay, you just return this. Okay, and we are taking the 2D array which I have said you, we will be storing our answer into a 2D vector. And now what we have done, we just declare a queue which is a tree node structure. Okay, tree node. Okay, and we just push the root element into a queue. Okay, and when we see that the queue is not empty. Okay, so suppose if we take the example like 3. Okay, so like if it is okay, so if we push 3, so okay, so queue is not empty, so it will be written false. So what is the size of a queue right now? So it will be 1. Okay, so it will be 1. So next time it go to the current state, and it will see that I is less than 0, I is less than s. Yes, it is 0, it is less than. So what is the element in the queue dot front? It will be 3. So it gives the temp variable as a 3. Okay, and now it goes to the pop state, and it will remove the element from that queue structure. Okay, and now we will see that what is the element on temp of left. So what we will do for making the queue, now the queue will contain. Okay, so now queue will contain 9. Okay, 9 comma it will be like, and we are also recursively sending the function for a right element. So what is the element for a right? It will be 20. So we will store 20. Okay, and after doing so, it will go again to the loop state, and it will see that 1 is less than 1. Okay, so it will not go into the condition, it violate the condition, and we will just store that what we have stored. Yeah. Okay, and after doing so, after doing the temp, after doing for left and right traversal, we have to store the temp value. So we will store in current is just a second. So what we do is current is equal to 3. Okay, so current is equal to 3, and just push back into the current element. So it will store 3. Okay, so it will store 3. Okay, next time. Okay, and now similarly. Okay, so if we go to the condition, like it will next time it will become 1 less than 1. So it will be violating the condition. It will not go into the loop condition, and it will go to the v dot pushback current. Okay, into this condition. Okay, so it will go to into this condition. Next time if we go to the while condition, it will say that our queue is not empty, and we will just store the element. So we just remove this, and what is the size? It will be 2. Okay, and we will again go to the loops condition, and we will see that we are starting from int I barabar 0 to I less, and what we are doing, we just take the queue dot front. So what is a queue dot front element? It will be 20. Okay, so no, sorry, it will be 9. Okay, so it will be 9, and we will just go to the 9 element, and we will see that we will just pop out that element from a queue, and we will see that what is the element in left and right. We will see it is null. You just don't push it anything. Okay, and similarly we go to the right element. Okay, and what we will do, we will just store that what is the element for that. It will be 9. Okay, and similarly we will go for a 20 also, and we will see that it is also not null. Okay, so we will just push back to our this condition. Okay, so it will be like become 9,20. Okay, so that's all. Okay, for other traversal you can do by yourself. It will be a very easy. And still, if you have any doubts with the code or anything, you can ask me on my LinkedIn, or you can tag me on Instagram. I will mention my Instagram ID to in a description. And still, you can ask me on a comment on YouTube. Okay. Until then, good night, guys. See you.